Um, Good afternoon. Welcome to my YouTube channel, Onkuru TV. Like you have known that we always give you details information about the science topics. Now, please, if you are new to this channel, I will urge you please try to subscribe, share and like. And if there is any questions, you can drop it in the comments link. Okay, today we want to talk about the redox reactions. As you all know from the word redox contains two words, that is reductions and oxidation. Reduction and oxidations. So redox reactions are the reductions and oxidations, those two words always go together. Those two words always go together. And what does it mean? It means transfers of electrons from one reactant to another. Redox reactions means transferring of electrons from one reactant to another. And it can happen in 2 weeks. Transferring of electrons can happen in 2 weeks. It can be in form of oxidation number, and can also happen in terms of ions, in terms of electrons method. Now, we all know that when we talk about the oxidized, anytime element oxidized, it means it's a reducing agent. And anytime element reduced, it means it's an oxidizing agent. It means that it's an oxidizing agent. Now, according to the questions on the board here, they say, consider the following redox reactions. Which of the species is oxidized? Which of the species is oxidized? We must go to the reducing agents. 3, reduced. Number 4, oxidizing agents. You want to know the ones that is oxidized. Like I told you, anyone that is oxidized, it is a reducing agent. Anyone that is reduced is an oxidizing agent. Now let's come to these equations here. When you look at this one, this is carbon 2 oxide. Copper 2 oxide. Copper 2 oxide. Now, so we have to write their oxidation number under it. Copper 2 oxide. Oxygen is -2, as you all know. And this one is what? Carbon monoxide. Carbon monoxide. That is carbon 2 oxide. Carbon 2 oxide. Carbon 2. And it's +2, -2. This one is copper at its ground state, at solid state. That's 0. Anytime you want to balance the redox reaction like this, you want to write oxidation number, anyone that stands in its ground state, the solid state, that's 0, without any reactions, that's 0. Now this one is carbon 4 oxide. Carbon 4 oxide. Carbon 4, that means +4 and -2. You have to label the oxidation number like that. Now, let's compare the reactant side to the product side to know which one oxidized, reducing agent, reduced, and the oxidizing agent. If you look at this copper here, are you getting it? If you look at the copper here and the oxide here, this copper, you will notice that this copper from +2 to 0, what happened is that it reduced. Copper reduced. Are you guys now? From +2 to 0, copper reduced. And what does that mean? That means copper 2 oxide here. That means copper 2 oxide reduced. And for copper 2 oxide to reduce, it shows that it's an oxidizing agent. That means copper 2 oxide is an oxidizing agent. Is an oxidizing agent. For copper 2 oxide to reduce, is an oxidizing agent. Now, let's go to look at the carbon here. Carbon from +2 to +4. Carbon from +2 to +4. What does that mean? That shows that carbon oxidized. That means carbon oxidized. That means the carbon 2 oxide or carbon monoxide. Carbon 2 oxide oxidized. And for carbon 2 oxide to oxidize, that shows that is a what? Reducing agent. Is a reducing agent. Is a reducing agent. That was that carbon 2 oxide is a reducing agent for it to oxidize. Now, that's that for that. That's that for that. In fact, in the practical aspect of redox reactions, we use oxidizing agent to test for reducing agent, and we use reducing agent to test for oxidizing agent. Let's take a look at another example. This is another example. We want to know which of the species is oxidized, reducing agent, reduced, the oxidizing agent. How do we know? Now, these are reactions. Like I told us earlier, that we have to state their oxidation number under it. Now, how do we know the oxidation number of Cr2 O72 minus? Now, for us to know, many of the chemistry students, they don't know how to pronounce a compound. They don't know how to pronounce a compound. I will teach us. Now, when you have a compound like this, how will you pronounce it easily? This is 7 oxygen. That is from our mathematics knowledge. That is hepta. No, 7 is heptagon from our mathematics knowledge. So if you want to call this one now, we have 7 oxygen. That is heptaozo. Now, but for you not to call it completely, you do a simple calculation. That will be Cr2. This is Cr2 is chromate. It's chromate. Heptaozo chromate. What is that the number we are going to attribute to it? This is a little calculation for it. What is the oxidation number of oxygen? That's -2. You multiply by this 7. That's -2 times 7 equals 2. So the valency here, you write it outside there. That means -2. Cr2 -2 times 10 is -14 equals to -2. You can bring this 2 back at the back of the chromate to stand as coefficient of it. 2Cr -14 equals to -2. You can bring the -14 to the back here. 2Cr equals to -2 plus 14. So it becomes 2Cr equals to -2 plus 14, that is 12. Divided by 2 over 2 over 2. So the chromate equals to 6. So if you want to call this one now, that means the oxidation number of chromate here is 6. So if I want to call it now, I'll call it what? Heptaozochromate 6. Heptaozochromate 6 AO. Because it is in form of AO. Heptaozochromate 6 AO. So that means the oxidation number for chromate will be what? +6. Oxygen doesn't change, that is -2. So the charge for this one is +1. This one is just +1. Charge for this one is +1. So the oxidation number for this one is +3. Chromate 3 ion. Oxygen here is, oxygen is +1. And hydrogen is +1. Sorry, hydrogen is +1. Oxygen here is -2. Hydrogen is +1. Oxygen is -2. If you have succeeded in writing their oxidation number, you are good to go. Now let's start comparing the reactant side to the product side. If you look at this chromate here, +6 to +3, what does that mean? That means chromate reduced. Chromate reduced. Chromate reduced. That means heptaozochromate 6 ion reduced. Cr2O72 minus reduced. And If it's reduced, what's that? It's an oxidizing agent. It's an oxidizing